Hi everyone, welcome to video. Today we are going to solve minimum distance between two given nodes of a binary tree. In this question we are given a binary tree and along with that we are given two integers a and b. We have to find whether these integers are present in the binary tree or not, and if they are present we have to return distance between them. See example 1. This is binary tree 1, 2 and 3, and we are being given a equals to 2 and b equals to 3. We have to find distance between 2 and 3. Okay, so as you can see, you can traverse from 2 to 1 and 1 to 3. So there is total distance of 2 distance from 2 to 3. Example 2, you have to find distance between 77 and 22. Okay, from here 77 you can go to 33, 11 and 22, or vice versa. So you will get a distance of 3. But how we will find it? There's a concept in binary tree known as lowest common ancestor, which means for any given two nodes a and b, it will be the deepest nodes which has both these a and b as common descendant, which means for 2 and 3 the lowest common ancestor is 1. Lowest common ancestor is 1 because 2 and 3 both are the deepest what descendants of one common node, lowest common ancestor. Okay, and similarly for example 2, for 77 and 22 you can find the lowest common ancestor being 11. Okay, being 11. So I will solve this question using lowest common ancestor. I will find lowest common ancestor and successively its distance from both the nodes and will add them and will return the result. So for this, we will take help of a utility function. Utility function will pass three values. First is root, and second is a and b. But here a and b are given as a value, not a tree node. So we'll need to convert them into nodes. Nodes first of all in order to pass. Okay. See, node definition of node is given over here. So first of all, I will create this utility function. Okay, def util, and what I have passed root A and B. A and B. Let's say node A and node B. Node B. Cool. Now there will be a lowest common ancestor, which I will calculate. Let's create a function lowest common ancestor to get the value of lowest common ancestor for nodes. Okay. Okay. Now there will be if there's no lowest common ancestor, which means either the value are not present or there is no path to reach. But lowest common ancestor will not be there if either root is not there or each in any of these node A or node B is not there. Okay. In that case, if not lowest common ancestor, if lowest common ancestor is not present, return -1. Okay. You cannot traverse from node A to node B. Cool. At the end, distance of node A from its lowest common ancestor. Again, I will create a function from node, and here it will be between root and node A. And similarly, we will find distance between node A, distance from node A to its root. Okay, distance from node A to its lowest common ancestor or root. Okay, and at the end, I will just return the summation of both these distances. This node B. Okay, at the end, we just return the distance of both these nodes. Okay. Now there are two functions to be created. First is lowest common ancestor. How to calculate it? And second is distance from node. Distance from given node to its okay ancestor. Then first of all, I will create the lowest common ancestor function. And since we have passed three values, root, node A, node B, three values. Now the base condition, if root is not there, or what if root dot data what if root dot data is same as node a dot data, node a dot data value of node a is same as value of root, or similarly there can be condition that value of root is same as value of node b. In all these cases return just root because we are at the place where we wanted to be. Okay, we have reached our lowest common ancestor. Okay, okay. Now I will find the lowest common ancestor recursively for left subtree and right subtree. For left, there is lowest common ancestor for root dot left node A comma node B. And similarly for right, lowest common ancestor root dot right node A comma node B. Okay, we have calculated the lowest common ancestors recursively for left subtree and right subtree. Now we'll check what if we do not have left subtree. In that case, we'll return the value of right subtree. Okay, and similarly, for what if we do not have right subtree, right lowest common ancestor for right subtree, we will return the value of left subtree. Okay, if not left, return right. If not right, return left. Okay, what if either of them are not present, both of them are not present? Okay, we checked if one of them, either of them is not present, return the other one. What if both of them is not present? What if there's no left subtree, no right subtree? In that case, what? In that case just return none, because we do not have anything, we'll return nothing. Okay. Now again, to reiterate, I created a utility function which calculates the lowest common ancestor. Okay, if there's no lowest common ancestor, which means there's no commonality between the given nodes and we cannot traverse from node A to node B. Okay, then we'll calculate the distance of node A to the root. Okay, and similarly we'll calculate the distance from node A to the node, okay, to the node B to the root. Okay, and at the end we will return the summation of both of them. How to find the lowest common ancestor? In a similar way. Okay, recursively find what is common between the values. When can we reach from node A to the a point where we meet, we collide? Okay, if we are given an example to 2 and 3, node 2 and node 3, how can we reach a place? We'll reach recursively upward or downward, upward here, and we have to reach a point where we have meet the data. See, we are going similarly for left subtree, right subtree. Okay, inward and upward, and we have to find when there's a place when the value of current root is same as node A's value, and value of current root is same as value of node B's value. Okay, and at the end we have to find how to calculate this distance. Okay, so here we have in the parameters we pass two values, root and a particular node of which we need to find distance. Okay, so we'll just stick to node and not node A and node B. But there will be a runtime variable, runtime argument, depth, which will find how many steps, See, how can you know? See, you just pass root and node A. How can you know that what is the distance between root and this particular node? How can you find? You'll need something, right? You'll need something. So I passed a runtime argument, depth. Depth is the number of steps you need to take to reach root from this particular node. Okay, current node, whether it is node A or node B. Okay, now the first thing, if there's no root, return -1. You don't have root, you don't have to reach anywhere, return -1. Okay, now what if root dot data same as node dot data? We have reached a place where we wanted to be, return the depth. Return the depth. We wanted to reach root right from the node, and what if we are at the same place? Return the depth. Okay, and now the obvious thing, reciprocate the same thing for left subtree and right subtree. Okay, left is distance from node, root dot left node, add to the depth, add 1 to the depth. But what if Okay. When left will be minus one. When left will be minus one. When we do not have any left subtree, we have reached the leaves. Okay. Left will be minus one. See, if not root, return minus one. When this will be minus one, when there is no left subtree possible from particular current position. But if there's a possibility to reach the left subtree, return left. When there's a possibility of having a left subtree, when there is left subtree, let's return that particular value. And similarly, reciprocate the same for the right side also. Root dot right node and depth plus one. So I hope we have reached the position where we wanted to be. Let me submit it and test. Okay, it's not root or okay, it's not. Okay. So see what we have do, what we have done. We have find the lowest common ancestor, and then we have okay, we first find out what is the lowest common ancestor between the given nodes. Once we have find out what is the lowest common ancestor, then we are finding the distance from that particular node to its lowest common ancestor, and then we have found the value individually, and at the end we have returned the result. Now let me check what I have done. What I have done here. Code output is 3. Code output is 1. Okay. Let me pause it and check. Okay, so now I may have figured out what I'm missing. So in this case, we will check the base condition. We calculated the same for the left subtree and right subtree, and we have returned if left is not present, return right, and similarly for right, and if both of them are not present. But what if there is left and what is there is right also? In that case, we had to take care of something. That is where we'll have to return root. We'll have to return root. Okay, that I may have missed. I have missed. I remember, and let's see. It should do the job. Still, okay. So now I know what I've done. I'm repeating the same thing very often. I have done very horrific mistake. I'm saying that we need to find distance from particular node A to the to its lowest common ancestor, and I'm passing here parameter as okay root, which should not be the case. It should be lowest common ancestor. That is why we have calculated the lowest common ancestor. Yeah, this time it did the job. So it took me a while, couple of attempts to figure out what I'm doing wrong. So see, these are some important things where you may be able to learn. And okay, so I hope you learn the concept and learn a valuable concept to look out what you are speaking. So thank you. Have a nice day.